Anyways, today we get to actually talk about probability. Yesterday, okay, well, let's talk about it in a minute. Today we're going to actually talk about probability. Yesterday, the only thing we were talking about is how many combinations can you make, how many permutations. We weren't actually finding the probability of anything. So first, let's talk about what probability is. What is probability? Ooh. What's the probability Kendall will shoot a grape into the trash can and make it?
Again.
So what's probability? Give me a synonym for probability. Chance. Likelihood. I like that. How likely is it to happen? Percent, chance, outcome. Okay. So here it is on the board. It says it's how likely an event is to occur. Each possible result is an outcome. So you can write whatever words you want from this on your page. Probability, this is what I write. I would write probability is the measure of how likely an event is to occur, and I would stop right there. Probability, how likely an event is to occur. Oh, you want today's notes? Is that what you're saying? Oh, this is today's notes, yeah, right here. Probability. How likely an event is to occur. And then each possible result is called an outcome. And if you take all the possible outcomes that there are, it is called the sample space. That's all the possible outcomes that there are. Sample space. Okay. And then an event is an outcome or a set of outcomes. Event. So I've got a die, or dice, plural. And so what is the sample space in a normal dice? Dice. 6 is the sample space. 1, 2, 3, 4, 5, 6. Those are all the different choices you have. In this spinner, what's the sample space?
4.
So you're saying how many items are in the sample space, but the actual sample space is red, blue, green, yellow. Okay. What in a deck of cards, this one would take us 52 times, but in a deck of cards, what's the sample space? You would literally have to name
everything and everything.
ace through king, and then you'd have to name all the hearts, and then the clubs, and then the spades, and then the dimes.
It's actually good spades, clubs.
How many cards are in a deck of cards?
52.
52 cards. How many of those cards are red?
26.
Half of them. How many are diamonds?
13.
13, a fourth of them. Very good. Okay.
I'm so
So we will be asking questions about that in a minute.
52.
Now-
That is worse than each.
Very good. Now, when you're talking about probability, if something is not likely to happen at all, what will its probability look like? Give me a number. 0. 0. So a very small number means it is not possible. It cannot happen. If it has a 0% chance of raining today, that weatherman better be sure it is absolutely not going to rain today. No chance at all. Now, if you're certain about something, and you want to say it as a percent, what's the highest you can go if you're 100? When people say they're 110% sure, that doesn't make any sense. 100 is the max. That is the max. You don't go above 100. But you can also write percents, not percents, you can also write probabilities as a decimal. So just to let you know, if you're writing it as a decimal, like 0.2, the very highest that you can get would be 1. It has to be between 0 and 1. If you're doing a percent, it has to be between 0 and 100. Okay. Do you remember how to go back and forth between decimal, fraction, and percent? Let's do one real quick. So I'm going to give you a probability, and I want you to tell me what that is in decimal form and what that is in percent form. 3 out of 8 times, Kendall made the grape in the trash can. 3 out of 8. What is that as a decimal? I know, that's bad. I'm sorry. What is it? 0.375? That's the decimal probability. What's the percent chance that he'll make the grape in the trash can again? Change that decimal to a percent. Remember how to do that?
No.
You either times 100, very good, or I just kind of think of it as move that guy over twice. If you move it over twice, what's the percent chance?
37.5.
37.5% chance that he'll make the grape in the trash can. And that's not really fair because he made it 1 out of 1 time. So far he's made it 100% of the time. Not 35. Okay. Theoretical probability. Write it down in the big dotted rectangle with rounded corners. Theoretical probability. In the numerator, you put the number of favorable outcomes, and in the denominator, you put the number of total outcomes. So it's favorable over total. Favorable out of all the ones in the sample space. Favorable out of all the ones in the sample space. So Omar, on this die, I'm giving Omar a crazy dice. How many things are in our sample space? How many outcomes are in the sample space on that die? 20. He said there's 20 on there. I want to know the likelihood that we roll an even number. How many numbers on there are even? 10. So the number that's favorable would be 2, 4, 6, 8, 10, 12, 14, 16, 18. Those are the favorable ones. And then he already told me the total, there's 20 numbers on that crazy die. Okay? So then you would always, every single time you would reduce. You would never write 10, 20 and says an answer, and that is obviously 1/2. Very obvious. Okay. So what you want to happen over the total. That's probability in a nutshell. All right. Each letter of the word probable is written on a piece of paper and put face down. And they're all mixed up. What is the probability that a randomly selected card is a consonant? Do y'all know what a consonant is? Waiting for someone in first period to tell me what a consonant is. I know.
The opposite of anything that's not A,
Brett is saying it's anything in the alphabet that is not a vowel. Y'all should know what a consonant is. Consonant, vowel. You never watch Wheel of Fortune? Seriously? Alright, so I want you to write down what's the probability that you draw a consonant. Go. Write down the probability.
Wait, does Y count as a vowel?
Y counts as a consonant.
How? There's no Y.
A-E-I-O-U. Oh, you're right. Why do you ask about Y? There's no Y up there.
Oh.
But yeah, if we were saying in the alphabet, you would need to ask me that question. I know one year I did this. I wrote the words, I wrote the letters probable on a card. I don't know where it went.
I know, I wanted to actually do it.
You redo it.
Yeah, I can redo it. It'll take that long, right? Nasia, what'd you get? Okay, so it's not going to be out of 26 because you need to. Let's start with this. Shelby, how many letters are in our sample space?
8.
Okay, I said Shelby, but okay. So your denominator should be 8. How many letters in the word probable are consonants? So where does that go? In your numerator. Okay, here we go. So, in your denominator, there's how many? 8. And in your numerator, there's 1, 2, 3, 4, 5. 5 out of 8. Can you reduce that? Because if you can reduce it, you have to reduce it.
No.
Can you reduce that? No, that's not reducible. There's no number that divides into 5 and into 8. What is that as a percent? What's the percent chance? 62.5. So it's more than half. It's more than half the time we should draw a consonant. Okay, Alea, go up there and draw a card. Oh, so what'd you get? A consonant or a vowel?
Vowel.
She got a vowel. Dimitri, go draw a card. Wait. Just shuffle. Okay. What What'd you get? B. What is that? Consonant or vowel?
Consonant.
Brett, come draw a card. Form a line. I need 3 more people. Form a line. 1,
B.
2, Matt, 3. B. What do you get?
Consonant.
Consonant. Go, Megan, go.
Oh.
What'd you get?
L.
L. What is that?
Consonant.
Consonant. Shake them up, shake them up. Go, Matt. What'd you get?
L.
L.
L. What is that?
Consonant.
Shelby, last one, go. B. She got a B. All right. This is called, I was going to get to this later, but let's get to it now. This is the theoretical probability. In theory, we should choose a consonant 5 out of 8 times. What happened in real life? How many times did we do this? 6 times. And how many times did we choose a consonant? 5 times. What is 5 out of 6 as a fraction? A decimal, sorry. That is a fraction. What is it as a percent? 5 out of 6. So everyone's doing 5 divided by 6. So it was supposed to happen 62% of the time, but in the real world it happened 83% of the time. That's the theoretical, right here, theoretical. And this is called experimental because we actually conducted the experiment. Do you ever do that in science? Do you ever predict what's going to happen, and then you actually do the experiment and you compare them, right? That's what we're doing today. Okay. Do any of you get lockers anymore?
No.
No.
I have a locker.
In gym, right? Okay, yeah. So anyways, you get a locker, and it's got a 5-digit combination. So there's 5 numbers. 1, 2, 3, 4, 5.
Yeah.
You only have 3 numbers?
Yeah, 3 numbers.
Oh, but some of them have 2 digits, right? Like 26 could be the middle number. Okay. What's the probability of receiving a combination with all odd digits? The probability of getting a combination with all odd digits.
What's it go to?
Wait, could a number be
0 through 9 are the choices, 0 through 9. So let's talk about the first number. What is the probability that that number is odd?
4 out of 9. 5 out of 10.
It's hard because it's 0 even or odd.
It's even.
So if 0 is even, it's neither positive or negative, but we'll call it even. So if 0 is even, then 0 through 9, you've got 0, 2, 4, 6, 8, 5 out of
4?
10. 0 through 9. We talked about that yesterday. 0 through 9, there's 10 numbers there. So 5 out of 10. You got a 5 out of 10 shot for it to be odd. What about the next slot? Still 5 out of 10, right? Half of the numbers are odd, right, guys? Half of them are odd. Half are even, half are odd. So in each slot, you've got a 5 out of 10 chance. What is 5 out of 10? What does that reduce to? 1/2. And we are multiplying these because when you want more than one thing to happen, you don't add them, you multiply them. And so we are really doing 1/2 raised to the what? How many times are we multiplying it by itself? 5th power. Can you do that in your calculator? Parentheses open. Parentheses open. 1 divided by 2. Parentheses closed. And then raise it to the 5th power.
1, 0, 3, 1.
Really small chance, right? Do math enter. And let's do it as a fraction. 1 over 32. Because we like to put our answers in all different forms. And what about as a percent? As a percent, 3.1%. A 3% chance that all of the digits will be odd. Probably one of those are going to be even, right? 3% chance. Okay. Now we're going to talk about a word called a complement. Is that on your notes somewhere? Complement?
No.
Complement of an event. Very good. The complement is really when you want to find all of the outcomes that are not favorable. So like, what's the probability I will not roll a 6? Well, you would find the probability of rolling a 6, and you would subtract it from
Total number.
1. Always 1, because 1 is the most it could be. So the complement, this is what I would write down. The complement is 1 minus the probability of the event happening. 1 minus the probability. That's called a complement. Kind of like complementary angles. You subtract it from 90. This time we're subtracting it from 1. Okay, let's try one. There are 25 students in study hall. The table shows the number of students who are studying a foreign language. What's the probability that a randomly selected student is, here's the key word, not studying a foreign language? So we're going to find the probability that they are studying a foreign language, and we're going to subtract it from 1. So what's the probability that they're studying a foreign language?
21 out of 25.
21, very good. Did y'all add those up? Is that how you got so fast? 12 plus 3 plus 6 is 21. There's 25 students in study hall. 21 of them are studying a foreign language. I want to know how many are not. So I subtract it from 1. You should write this down in your notes because you're going to forget how to do this and you're going to need to look at it again. 1 minus the probability that it does happen. 21 out of 25. You don't even have to use parentheses on this one. It's pretty cool. 1 minus 23 out of 25.
21.
Math, enter. 2 out of 25 or 8%, right? So y'all got?
Wait, how do you find the percent?
You just moved the decimal over twice. Didn't you get 0.08?
No,
Oh, then I did it different.
23 was 21.
Oh, it was 21. I did put 23. How'd you know for 23? Was I talking out
heard
loud?
you, yeah.
Ah, awesome.
And it's 16%.
16% or 4 out of 25. It's good to know the different ways to write the answer. 4 out of 25 or 16%. Very good. Geometric probability. Okay, it doesn't say the definition. Pretty much you're just finding the probability that something will fall in the shaded region. So we've got this figure. It's created with a rectangle inside a rectangle. And I want to know, if I shoot a dart at that, what's the probability I will land in the shaded region? So you're shooting a dart at that figure, and I want to know the probability that it'll land in the shaded region. Go. How many times will it land in the shaded region? What do you have to find?
Area.
Area. We want to put
9 area.
the area of the shaded
Is it 8?
over the total area. Shaded over total. The total area is the easiest. Melanie, what's the total area of that rectangle? What's the area of that rectangle, the big rectangle? What? Multiply length times width? Base times height? $40. All right, so the total area is 40. That's our sample space. It's called a sample space. Now, in the numerator, we want to put the area of the shaded region. That's a little bit harder. We want to do something times 5, right? Length times width. What is this and this together add up to? 8 minus 2. Very good. 8 minus 2. So that's 6, and that's 5. 6 times 5? 30 out of 40. Oh, I can reduce that in my head. 3/4.
I did it different way.
Okay, did you do a complement?
I did 5 times 2 minus 1.
That's a complement. You subtracted it. Very good. 3/4, or in other words, we have a 75% chance that that dart will land in the shaded region. Cool. Last one. We've already talked about this a little bit. Experimental probability is the number of times the event occurs, what you want to happen, and then over the number of trials that you do. So earlier when I had people come up here and they drew the letters of the word probable, the number of trials we had, we only did 6 trials. We didn't do all 8. We did 6 trials, and then how many times did it occur? It was 5 times. 5 times it occurred out of 6. So, let's say we're flipping a coin. Do I have any ready to go? Does anyone have a coin ready to go? I usually keep one right here. I don't have my little coin that's usually right there. Anyone have a quarter? We can just do it on the smart board. We'll do it on the smart board. So, in theory, when you flip a quarter, how many times should it land on heads? Okay. We'll do it on here because I'm going to bring this around the room. In theory, how many times should it land on heads? Half the time. So 1/2 or 50%. This is called theoretical probability. Now I'm going to go around the room, and when I bring the iPad to you, I want you to press start, and then whenever you feel like it, press stop, and then we will document the results. Okay? Can I have someone on the board document the results? Torrin, go. All right. Ready? Press start. You just press stop.
I just walked up and right too slow.
Heads. Start. Heads. Oh my goodness. Julius, you want to do an experiment? Press start. Press start. It's going. Now press stop whenever you feel like it. Tails. Heads. 11 untouched. Okay. Very good. We'll stop right there. Uh-oh. Was our theory the same as our experiment? No. Not even close. What was the experimental probability?
Couldn't have been even if you did 5 times.
I mean, we might, sometimes it takes 50 times, sometimes it takes 70 times to get to make it match.
I wouldn't.
Yeah, we would have had to keep going for a while. So what is the experimental probability? You always put the total first. What's the total? We did it how many times? 5 times. You always put the total in the denominator every time, no matter what. How many times did we land on heads? 4 times. So there's the theoretical. Theoretical is 1/2. That means in theory, 1/2 of the time. But then experimental was 4 out of 5. Okay, getting close. The table shows the results of rolling a dice over 3 separate experiments. What's the experimental probability of rolling a 2 in experiment B? So what's the experimental probability that they rolled a 2 in experiment B? So John, what should everyone be doing first? Your name's not John. What? Go ahead, John.
I was going to say, what she said.
What did she say?
I don't know what she said.
So, what? What should you do first?
Find the
Denominator. Yeah, let's add them
I couldn't
up.
think of the word. I was like,
Okay, let's add them up. 4 plus 4 plus 2 plus 5 plus 1 plus 4. 20. Well, that's easy.
On the 4.
And then we want to know the probability of rolling a 2. 4, they rolled a 2 4 times out of 20.
Well, same thing.
You cannot put 4 over 20 as your answer. You will get it wrong. So what do you need to do to that 4 over 20? 4 divided by 20, math, enter, enter. What do you get? 1/5. 1/5. 1 out of 5 times they rolled a 2. What's the experimental probability of rolling a 4 or higher in experiment C? Matt, what do we got to do first? What? Count them all up. 5, 6, 7, 7 plus 6, 13, 14, 15, 16, 17, 18, 19. Oh, they did it 20 times again. Okay, that's easy. 4 or higher.
So it's going to be 3.
What are we adding up?
3.
4 or higher. 7. Is that reducible? Nope. So we're done. You can change it into a percent. It just depends on what the question asks you to do. All right, final example of the day. I put every math teacher's face on this little interactive thing, and every time you click it, it changes to a new math teacher's face. So we're going to find the probability of rolling my face on that die. Now, there are how many teachers? How many names are up there? You're quite kind. There are 8 math teachers. So what's the theoretical probability that we're going to get my face?
1 out of 8.
1 out of 8 is in theory. We're going to see how many times it happens in real life. Okay, let's go to everyone who didn't get to roll the just quarter. Yep. Just click on it once. Okay. Oh, I need a ticker to run again. That's Saunderstead. So put a tick on Saunderstead.
I don't know.
Just click the face. That's literally all you do. Laird. Sond. Yeah. Laird. Let's let everyone do it. Pacer. Johnson. Pacer. Aguade. Bruce. Oh. We are being recorded. Saunderstead. Just click the face. Tanton. Excuse me? Laird. Very glad I don't get offended by things like that. Snake. Pacer. I think he's winning.
Ooh.
Bruce. Tanton. Smink. Guade. Laird. Johnson. And Saunderstead. Woo! Oh, you didn't get to do one? Johnson. Wow, okay. So at least every teacher got clicked at least once. That's good. So what's the experimental? Did I get to everyone? Did everyone get to click it? So we said there's 19 people in here, right? So 19 people was our denominator. And how many times did we click Tanton?
2.
So I want to know what this is as a percent and what this is as a percent. Let's see how close we got to the real thing.
That's 20.
That's 20.
So someone did it twice?
20.
Oh, ooh, sorry. I let Lewison do it twice. All right, so 1 out of 8. Well, this is easy to compare now that it's 2 out of 20. 1 out of 8 is what should have happened, and it happened 1 out of 10 times. So it happened a little bit less than what should have happened. Does that make sense? This lesson is now over.